Camera for 2D consists of a primary camera controller script and then a variety of scripts that interact with that to do different effects. Let's take a look at this camera controller script. It's attached to our main camera, and as you can see there's some basic options here. Which axis we're operating on, in this case the XZ axis. The layer to use to be considered blocking for our camera bumpers. Those are areas in which the camera is not allowed to push into. So for example, we have a bunch of screens that want to act like Zelda style, one screen at a time, and thus we have camera bumpers that go all the way around, just such that the screen cannot move until you get right to the edge. We'll look at that here in just a moment. Other options are things such as the height from the camera. This is along the up vector, which in this case will be the Y, and max move speed per second. A target. This is not the only target, but it's just the initial target. This is equivalent to calling add target from within code. We have damping, which is a factor by which the camera's movement is slowed in moving towards its desired position. This is what allows you to have a squishier feeling camera, something that lags behind and very smoothly eases in and out. And then we have arrival notification distance, which is how close the camera has to get to its target before the various callbacks that relate to arriving at a target happen. So let's go ahead and run, and we'll see what this draw debug lines thing is about. And as we can see, we have a bunch of different lines. Green means there's no intersection, it's not colliding with anything, and red means we have collided with something that is on the camera bumper layer. As you can see here, our camera bumpers are at the level of the target, not at the level of the camera. And then down below here, we have no camera bumpers. So if we were to move down in this area, there will be no restriction of the screen, and we'll just have green all the way around, and the camera will directly follow our target. Versus up here, the camera stops moving because we're running to the camera bumper. Now let's take a look at the way the camera seeks towards its ideal position. So the camera script, the camera controller script, upon instantiation will create a camera target object. This is an object that if you want to, you can move around on your own, and it will be the place that the target seeks to. By default, if you're not in an exclusive mode where you've taken control, it is moved towards the center point of your target. So if you have one target, it's right on top of the target. If you have multiple targets, it's the midpoint of all those targets. And as you can see here, we have two colors in our debug lines. We have an orange and a magenta. The orange is where the camera wants to be. That's where the camera target is, as you see here. The magenta is where the camera is being forced back to. So in this case, we're close to these walls here. So the camera is forced back to this point right in the middle because of how close we are to the walls. If we were in a exclusive mode, which is you can achieve through code, you could move this camera target wherever you wanted to, and based on your damping and other options like that, max move speed, it would follow, the camera would follow along and seek towards that target. Now let's take a look at what happens when we move through. We have a camera bumper right here, and as you can see, our line is getting smaller. And as we cross that, all of a sudden, instead of the camera bumper being to the right, it's now a little bit to the left. So, as you can see, the desired position, or the actual position, the magenta, shifts. And these camera bumpers are set up to be exactly the size of the screen, so the only place it can go because of the pushback from the edges is right in the middle. The two factors that will most significantly impact the effect or the feel of your camera are the move speed and the damping. So let's take a look at those. Currently we have a very high move speed, 60, and as you can see our screen moves very rapidly from one spot to another. If we take this way down, you'll see that we have a dramatically reduced screen push. This can feel more modern in some ways. It might also feel less classic, less effective, especially if the player can move. So you'll need to mess with this to establish a screen push that feels correct for your game. And then in this area, it's not very easy to tell, but if we move down here to the sort of free movement area of the demo, we can mess with the damping. So currently it's set to 0.015, which is basically the smallest value that will have an effect. If we set this to something much higher, let's say 0.3, and then move, you'll see that the screen lags visibly behind where the player is. So you can see the desired point and the actual point is lagging quite behind. We can see a more extreme example of this. If we increase it even more, it just takes a very long time for the camera to get up to its max move speed. If you don't have the max move speed set high enough, then your character, no matter how low the damping is, your character will move away from the camera. It'll physically separate itself from where the camera is. If your project only uses a single target, then you can easily just set that on your camera here initially and never worry about it again. However, if you have a situation where, such as in the demo here, pressing a button needs to pan the camera to reveal the effect of that button and then pan back, you'll need to write some custom code to interact with the camera. In this case, there is a add camera target when touch script. This is not part of the camera itself, but it interacts with it. And let's see what happens when we touch this. We see a new target is set, and we pan over to it, and then after a delay, we pan back. Now let's take a look at the code that's behind this. So this is doing more than just adding the target. It's also triggering a tween, but let's look at the camera interaction parts. This is the most basic example. You add a target, and then you can specify a move speed for how fast to pan to that new target. This doesn't override the move speed of the camera, only while panning initially for the first time to that new target. A more complex version is here, where we pan to a target, and then after delay, we pan back using this revert move speed. This is useful, for example, in the upper chamber of the demo, where you pan across an area and then very quickly pan back to the main player because you don't want to pan slowly in both directions. This script does a few extra things. It starts a tween when the camera has reached its target, and the way it knows to run this is there is a on new target reached delegate on the camera controller. So this is a callback, and you can just assign to it. You could either assign to it directly, or you could add to all the callbacks that are being run your method. In this case, it's a method that takes 0 parameters and returns nothing. And all it's going to do is it's going to play a tween that's on this target, and then it's going to remove itself so that it no longer receives notifications about the camera reaching its target. If your game has a situation in which you want to have multiple targets focused at once, you may have need of dynamic zooming. So here's an example from the demo. We're going to press this button. This uses the same script as before, add camera target when touched, except this time it doesn't add 1 target, it adds 4, and it doesn't do any of the remove or tween stuff that the script was doing. It's simply going to add 4 targets. And as we see here, the target of all 4 targets now is right in the middle, and as we move around, it's going to dynamically move around. The other thing that's happening is on our main camera, we have our keep focus targets on screen script going. This again is just another script that interacts with the main camera, and what it is adjusting is a magnification option. And we'll take a look at that in the code in just a second. But as you can see, what happens is as our target, 1 or more targets, gets near the edge of the screen, kind of a little border right here, the screen is zoomed out and thus scales back so you can see more of it, up to a maximum. And as we get everything towards the inner portion of the screen, there's a configurable border on it, right here, 0.16. If everything is within 0.16 of the edge, or more, closer in towards the center, then the camera will zoom in down to its default of 1. And then similarly, if you are 0.07 of the screen's width, if you're within that of any edge, then we zoom out. So let's go take a look at what this is doing. So this looks complicated. There is a fair amount going on here, and you can take a look through it in the demos. But the main thing that's happening here is that the distance multiplier, which defaults to 1, is being modified. This distance multiplier, if you were to say set it to 2, it would double the equivalent distance. So for ortho, that's the ortho size, and for perspective, that's the actual distance from the target. So it doesn't matter what you set that to, the multiplier is relative. So if you set it to 1.5, things will be 30% smaller on the screen. If you set it to 2, they'll be half as small because you'll have zoomed out twice as far. And so all this does basically is it figures out if any of the points are near the edge or if all the points are in the center, and it sets zoom out or zoom in appropriately, and then we act on that. So if we're zooming out, we check to see if we go past the max. If so, we just set it to the max. For zooming in, we see if we zoom in past 1. If so, we just set it to 1, and we apply the zoom. The only thing that I would make note of here is that as you're zooming in and out, the screen bounds. This is the area that's calculated here for where to check where to send these lines. That is a relatively expensive operation, a bunch of matrix multiplication to get all of those set up. So we don't want to do that every single frame as we're zooming in and out. So at the very end of our zoom, if we had been zooming, we mark need to recalculate screen bounds. And then when we're all done, if we're not zooming in or out, but we had marked that we need to recalculate the bounds, then we'll go ahead and recalculate that once. This isn't done every frame because it'd be too expensive, so it's up to you to recalculate that if you're going to be messing with the depth. Finally, let's look at one remaining way that you can manipulate the camera's desired position. This time we're going to be looking at the idea of camera influences. So a simple way of thinking about this is the position that the camera is at is pulled by something in the scene. So we have a point of interest right here, and as we walk closer, you'll see that the desired position and the actual position are offset, and this orange line here represents the influence that the point here is exerting upon our target. As we move closer, it gets closer. As we move further away, the influence is less. That way there's a nice smooth transition in and out. So let's take a look at what is actually making this happen in code. Right here we see the camera controller add influence and then a vector. That vector is just directly translates to the vector in the scene in terms of how far we want to offset our position from our initial desired position. This is sort of the same system that the pushback uses, although they're independent. The pushback is going to override any influence. So even if you want to influence through a wall, pushback will still push you away from the wall. Currently we only see one line. This is the total influence is the same as the influence from this one object, but you can have a system in which there are multiple influences. As an example of that, we can set the look ahead on our player. What this does is the look ahead pans the camera forward ahead of where you're walking. So we're not within the influence of this point of interest, but we are still seeing that there is a offset between the desired position, or the ideal position, and the position that the camera is actually going to go to. And if we move over here near the point of influence, we'll see that there are two influences going on. This is the look ahead, and this is the point of interest, and together they sum into this magenta point right here, which is where the camera is actually looking. So you can have as many points of interest, or sorry, as many influences as you wish operating on your camera at the same time. Another use for this might be having a character where you want to semi-permanently offset the camera away from them. You could, in its update, go ahead and add a permanent vector, say like a -5 in the x direction as an influence, and that would just shift the ideal point over. One thing to note here is that this is done inside update. Camera influences are cleared every frame, so if you wish to keep applying the influence, you need to do that in something that's called regularly.